Okay, moving on to number 5. Doing the tan of 15 here, and this is just like the last problem. We're going to be using the sum and difference formulas to create a 15-degree angle. One way to do that would be to use tan of 60 minus 45. Then as soon as you decide on the numbers you're going to use to split up the angle to create 15, then you're going to use a formula to expand this difference. The formula for tan is tan of 60 minus tan of 45. So you sort of have a distribution of the word tan on the top. Bottom left-hand corner, there's a 1. Take the sign and switch it, and then do a product of tan of 60 and tan of 45. Okay, then coming over here, you need pictures. Unless, again, as I mentioned previously, if you haven't memorized the numbers, the tan values at 60 and 45, then you don't need it. This is the picture at 60 degrees, 60-degree right triangle. This would be the long leg. This would be the short leg. This would be the hypotenuse. At 45, it's 1, 1, and square root of 2. Okay, now you can start plugging into this, looking at the triangles as you do so. So tan of 60 has a definition of y over x. So every time you do tan, you'll be using that definition. Tan at 60 is square root of 3 over x. And then minus tan of 45, which is just 1. Then in the bottom right-hand corner, you have a 1 plus. Then we're doing a product of the two values that we've already found at the top, which are square root of 3 times 1. From here, you're just simplifying. This is square root of 3 minus 1. And on the bottom, 1 plus square root of 3. Attempting to rationalize the bottom, you're going to have to multiply by the conjugate, not just square root of 3 because of the plus sign. The conjugate is the same expression with the opposite sign in front of the radical. To multiply the top by the same thing. Okay, remember there is a shortcut for foiling the bottom, and it's square minus square. Okay, so on the bottom, when you do square minus square, you just look at one of the parentheses, and you square the front, you square the second term, and then you put a negative in between the two squares. So our bottom turns out to be -2. Now let's FOIL out the top. Now these are not conjugates, and it's not the square of a binomial, so you can just go ahead and FOIL it the traditional way, which is square root of 3 times 1, square root of 3, square root of 3 times square root of 3, positive times a negative would be negative. Then multiply this by everything over here as well, so that you're doing all 4 parts of foiling. -1 times -1, -1. And then negative times a negative would be square root of 3, positive. Okay, combining like terms, you have 2 square roots of 3, 1 plus 1, you're adding those coefficients in the front. And then -3 combined with -1 is -4. And then each of these coefficients are all reducible by 2. And you're probably going to want to get rid of that negative that's in the bottom, so divide by -2. This coefficient, and this one. That leaves you with you're dividing by -2 in each case. That leaves you with square root of 3 with a negative in front of it. And then -4 divided by -2 is +2. And then -2 divided by -2 on the bottom is 1. So this is your answer, which you can leave like that. Or you can write as 2 minus square root of 3. Usually the integer is written first and then the radical whenever you're giving a number like this. Okay, next problem is 6. Starts off as cosine of 7 pi over 12 times cosine of 5 pi over 12 minus sine of 7 pi over 12 times sine of 5 pi over 12. Now in these problems you're working the sum and addition formulas backwards. Here they've given you the expanded version of the cosine formula. Okay, and that you recognize it as a cosine formula because it's got a homogeneous product in the front, homogeneous product in the back. So this is the cosine formula. Remember with the cosine formula is that when you are considering the sign in the expanded version versus what's in the parenthesis, they are opposites. And then the two angles that are mentioned in the problem are 7 pi over 12 and 5 pi over 12. Adding the two angles inside the parentheses, you get 12 pi over 12 or just pi. Okay, then you are to evaluate. Anytime there is a location on the circle that you can rotate to and go and pick up the x and y coordinates, you continue with the problem. So rotating to 1 pi on a unit circle. This is the pi location. Switch your focus now to x and y coordinates. The point that you're at when you're at pi, if you're on a unit circle, has a x coordinate of -1 and a y coordinate of 0. Using the definition of cosine on these x and y coordinates would give you x is -1, y is, it's x over r, the r value, that's the y value, so r would be in a unit circle 1. And -1 would be your answer. Okay, on to number 7. Number 7, same thing. It's already in expanded form. This time they're giving you the tan formula. Again, these are still the sum and addition formulas. Recall that when you're doing the tan formulas, there are two expressions, either added or subtracted on the top, both involving tan. Then there's always a 1 in the bottom left side of the fraction, and then a product of the two tan values that were on the top in the right corner, bottom right corner. So if you were to put this back together, it would look like this. Basically looks like what's on the top. It's tan of 50 plus 10. That's when you're going back the other way from the expanded version to the condensed version. Basically looks like the top. Now you're at tan of 60. Again, every time that there is a angle in front of a trig function that you can rotate to and evaluate further. You need to do that. So I'm rotating to 60, recalling the numbers that are there. If this is 60, that would make this the long leg. This would be the short leg. This would be the hypotenuse. So using the numbers in the triangle and the definition of tan, which is y over x, you get square root of 3. That would be your y value. And the x value is 1. So answer, square root of 3. Okay, so you went all the way from this expanded formula all the way to 3. And that completes numbers 5 through 7.